What are we going to do?
We're going to review the booking notebook. Yes, have your booking notebook. We're going to review first the information of the last class. Remember that we talked about what happens when the light hits an object. We review the meaning of a visible spectrum and the different light sources that can be from human made or from the nature. Who can tell me some light sources that comes to your mind that you can get the light? Light sources, class, where you can get light from televisions, from your cell phone. You can get light from a candle, from a flashlight, light bulb. All this gives you light and also the sound, the stars. We talk about transparent, translucent. Do you remember this, that we talk about transparent, translucent, and opaque? That an object that allows the light pass through so easily that you see everything, whatever is behind, it can be seen, it's transparent. We consider transparent. When it's translucent, when the light pass through, but not all the light. So it can be like fluffy, so it scatters, it scatters the light, and whatever is behind cannot be seen clearly like in transparent. And opaque, you cannot see anything. You cannot see anything. We give some example. That is the book, for example, opaque. It looks like this. You don't see anything. Translucent, you can see something. The colors, it can change the real colors because it's translucent, the object. And transparent, you see everything with the proper and the right color. And we talk about different objects like the glasses. It can be different colors, transparent, translucent, and opaque. So you're going to see that. We're going to watch a video, but before watching this video, I have one activity here. So let's, as a review, we're going to identify if it is transparent, translucent, and opaque. So I want everybody participating for this activity. What about this one, class? A window glass.
Transparent.
Okay, it's transparent. Let's check. That's correct. Look at the picture here to identify it. What about this object?
Opaque.
Opaque.
Okay, perfect. What about next one? Number 3.
Transparent.
Transparent.
Transparent. A blue glass is considered transparent. Blue glass, yes. What about this?
Translucent.
Translucent, that's right, because we have the curtains. Excellent. What about the cardboard?
Opaque.
Opaque.
Perfect. Let's see number 6.
Opaque.
Opaque.
No.
Translucent.
Yes.
It's transparent. You cannot see it, the air, so it's considered transparent. Okay, the book.
Opaque.
Okay.
Opaque.
Okay. What about number 8?
Hello. Fabric.
Opaque.
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 This is translucent.
Translucent.
Yes, you might see something, not clearly, but you might see
Water.
some water, potable water.
Transparent.
Transparent. That's great.
Okay.
Mhm.
I did.
Now, this
Wow.
information, the light can travel completely through this material.
Transparent.
Transparent, yes, it can travel completely. You can see it. Now, we have another information. Light cannot travel through this material.
Opaque.
Okay, yes, because it's a cannot travel. And we have light can travel partially.
Translucent.
Translucent. That's right.
Okay.
And this one, we can
Wow.
see
What
objects
is this?
blurry through this material like this.
Opaque.
Translucent.
Translucent,
Translucent.
that's right.
Translucent.
And we can see objects through this material.
Opaque.
Opaque.
Okay, that's right. You did a great job, class. You did a great job. Okay, let me stop sharing. We're going to watch this video, so pay attention. Then we're going to share what you understand about the video.
The light is the light of the sun.
Mhm.
So if rain and the light of the sun can be make a rainbow.
That's right. So that's why you see like a rainbow here. So today we're going to learn about the reflection of this. So it looks like a rainbow. That's why. Excellent. Now we're going to learn about what happened when the light, this light that we were talking about, can passes through and we can see in different ways. So we're going to learn about the concave and the convex way. So we're going to read, I don't know if you have your book, this is page 100, B107, I don't know, I don't remember the number of the page, but we're going to read from here. So we're going to take turns. Who wants to be the first one to help me to read fast this page? Rebecca? Okay, Rebecca, you're going to help me to read the first part.
How light beams? Why do you think the stems of the flower in the picture seem to be broken? The stems look broken because they some beams or attacks directions. Have you ever ride on snow is so you know that you can't run as fast as on soiled ground. Life also travels at different speeds, shows different materials. However, when they exchange space also change direction, light bends when it's moving from one material to another.
Thank you so much, Rebecca. So here is how light bends is what we're going to talk about. It says, why do you think the stems of these flowers in the picture seems to be broken? Let's look at here. Do you see here the picture? The stems, it looks broken, but they are not broken. So here is explaining why. It says that they look broken because light sometimes bends or change direction. This is because of the light that is reflecting here. And there's in the water, the stems of the flowers. So that is why it looks in this way. So we're going to learn more information here. We're here, right? So the light bends when it moves from one material to another, it says. Let's continue to the second paragraph. Who wants to continue? Continue reading, or you don't see this information, no? Lucia, help me to read the second paragraph, Lucia.
The light rays that reflect from the top of the flowers in the vase move through air. These rays do not bend. The light rays that reflect from the stems in the water travel back through the water before they reach the air. Light travels places through air than it does through water. When these rays move into the air, they change speed and bend. The systems look broken.
That's right. So it's explaining how the difference of the way that the light rays is going to change the reflection of the stems. So it says if the light travels faster through the air, than it does through the water. So this rate is going to look in a different way. So it depends of the light that it's going to look the object in one or another way. But let's see some examples later. Now let's continue with the reading. Gabriela Gigurens.
Notice that the lenses in the picture on the next page. A lens is a transparent object that is at least one curved surface. When light moves from Earth into a lens, the light bends. Lenses bend light in a way that makes an image.
So here it says, here it's asking us to go to next page. Notice the lenses in the picture on the next page. A lens is transparent object that has at least one curved surface. And here we have the lens, convex lens and concave lens. So the light is going to go through, it looks like this. The light can pass here like this when it's convex and concave in this other way. In next slide, I'm going to show you example. Right now, it's just the information in general. Let's continue here. What is the information that it says here?
The lens in the first picture boggles in the middle like a football. This kind of lens is a convex lens. Notice how the convex lens bends the light. Each other your eyes has a convex lens. The microscope in the pictures also used convex lenses. The lens in the second picture is thinner than the middle than the edges. This is kind of lens is a convex lens. Notice that the convex lens spread light rays apart. Wait. Still apart. A convex lens makes objects look smaller.
Excellent. So the information here, convex lens, examples of convex lens. It says the microscope. It's an example of a convex lens because of how is the light going through. The convex lens bends the light. And also it says your eyes is another example of convex lens. But concave lens is something different because it says that the edges, sorry, it's thinner than the other of the edges. So it says that concave lens, we are going to have some examples of the light rays apart. So we're going to see some example in the next one. Here is just the information. But before going to the example, let's copy this class. Let's copy these two definitions. What is a concave lens and complex lens? What is a concave lens? So there are lenses that it's thinner in the middle than in the edges. Just the information, do not draw, do not make drawings, just the information. And it looks like this. When you are seeing something in the concave lens, it's thinner in the middle than on the edge. So that's why you see it's thinner in the middle and the edges is going to spread here. And it's the contrary, the convex lens. The lens, it's thicker in the middle than on the edges. So here we have some examples of using convex lens like the magnifying glass. This is going to be why, because in the middle, it's going to be thicker and in the edges, it's going to be thin. The same happened with the microscope. But the concave, that is the first one, the spy hole in the doors. I don't know if your house or you have seen houses that they have in the door, this is spy hole.
What is the topic?
Topic. It's the same of the last class. You can use the same space. And this is the question for this information, how light bends. So the spy hole in the doors, when people they are inside of the house, they can use this to see who is outside of the house without being seen. So this is an example of concave. So when you're outside and you are trying to see inside using the spy hole, you're not going to see like the person that is inside of the house at the other side of the door. And the flashlight also. Let's copy this. Copy this in your notebook, class. Okay, let's check the attendance. Ana, Andrea, and Camila.
Present.
Dice Camila Ladna Macunar.
Present.
Okay, thank you. Gabriela, Isabel, and Kiara.
Present.
Present.
Lucia, Mia, and Rebecca.
Present.
Present.
Rosa, Valerie, and Sian.
Present.
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 Okay, Alberto, Dani, and Fernando.
Present.
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 Hermes, Joshua, and Caleb.
Present.
Marcelo, Santiago Hernández, and Santiago Chávez. Santiago Hernandez.
I finished.
Santiago Chavez, did you finish?
I finished.
No, I don't finish.
No? Tell me, Caleb.
Are we going to copy more?
I think that we're not going to copy more. I'm not sure. Just this slide you have copy, right? I think that this is the only one.
Only one. The other, the three slides, the rest are in the book or what?
Yes. Some examples. In next slides, I'm going to show you examples of concave lens and convex lens. Some examples, more examples. Here we have in this picture some examples, but in the next one, I'm going to show you more examples. So remember that a convex, the second definition, a convex lens, it's thicker in the middle. So it means that the light rate, there is going to be focus in something. It's going to be focused on one point, or it's going to converge. Like the magnifying glass in the convex, we have the magnifying glass. When you are focusing, you are using this, or like you say, una lupa in Spanish, you are using that. You want to focus, you want to see something, you are looking something. So you use a magnifying glass to see it, right? So you can be in one point, just one point looking or seeing something, or it can converge, you can move it. The same happen with a microscope, where when you are using a microscope, you are seeing one object and you are focusing in one point. The same, it can happen with a camera. Well, the cameras of now on the cell phone, they can have a convex lens. Your cell phone, if you see the camera, they might have some option that is set. Not all the cell phones, but some they can have it. And the convex lens. And the cameras that you see, the people that they are taking pictures of the streets, that they work as a journalist, people that work in the news, they have these types of cameras that they have a convex lens. And concave lens, well, in concave lens, as I was telling you, the lens is thinner in the middle than in the edges. So it means that the light rays move from one each other, from the sides. So it can be spread out, you can see it bigger, or it can diverge. Like here, like the spy hole.
I finished.
Okay, like the flashlight when you're using, for example, the cars headlights, the lights of the car, they have this, the concave lens.
I have a spy only in the door.
In the door, you have one spy hole in the door in your house.
Yes.
Okay, so if you later after the class, you can go and try to see in the spy hole how it looks, and now you know that this is a concave lens. It's an example of concave, a spy hole. When you are inside of your house, Khaled, when you're inside on your house, you can see the people that it's on the street, right? But if you are outside of the house, it's not going to be in that way.
Adentro de la casa que está el costo. Porque tiene dos puertas, tiene una de aluminio y la de madera que tiene el coso, el ojo del
spy hole. Okay, got it.
El de aluminio que le estoy diciendo tiene un portonzote que se mira todo bien clarito.
I finished.
That is the function of that, the concave lens. Excellent. Valerie, tell me, Valerie.
No.
What is the topic? I don't copy.
The topic of the last class is the same. We're continue writing about that. So you can write as a title how time fits. You didn't copy the last class, the topic? No?
A spy hole in the door look translucent.
Yes. What is the topic, class? What was the topic of the last class? Who can tell me the topic?
What
What
happens
happens
when
when
light
light hits
Happens when the light
an object?
hits an object.
Thank you. What happens when light hits an object? There it is, for in case that you don't copy that topic in the chat. Rebecca, tell me, Rebecca.
One thing. I finished and today is March, yeah?
Today, March 3rd. Yes.
Thank you, Miss.
Welcome. Finish class. Can I change the slide now?
Yay!
Yes.
Yes!
Yes. Thank you, Rebecca. Thumbs up if you finished. Thumbs up. I'm going to be checking your videos.
Bye.
Let's see who finished. Okay, thank you. Okay, thank you, Kiara. Thank you, Valerie. Thank you, Alberto. Okay, let's go to next slide, class. We're going to go to next slide. We're not going to copy. We're going to see some examples about this. Look at here. We have examples of the convex and the concave lens. Look at here. In the convex lens, remember, the light rays goes in this way that we were saying that it was thinner in the middle and thicker in the edges. So the light rays goes in this way, like this. Examples, the telescope, microscope, camera lenses, these types of cameras, even the cameras that we have, they can have some of these lenses, the cameras of the cell phones, but not all of them. The magnifying glasses and the eye lens. But what happened with the concave lens? There are some examples of this. The light rays goes in this way. It can go thicker in the middle, and it can spread out like the binoculars, the telescopes, the eyeglasses. There are examples. The flashlight, and here I'm going to say also another example for the concave, the projector. Do you remember? I don't know if you have seen at that data show that we say data show. Have you ever seen a data show, class, or not?
What is the what is?
Data show.
That shows
Un proyector data. I think
No.
yes. At school there were one on computer. Computer, yeah. At school you have one. Yes, so
Yeah.
it's a projector. It's a projector that you can display something, and that is going to project in another it can be, for example, in the board, in the whiteboard. You can project something so everybody can see it. So that is an example of a concave lens. It's projecting, so it's going to show you the picture in a bigger way. So that is another example for concave lens. Yes. Now, any question about concave lens, class?
no.
No questions. Everything is
I
clear.
don't understand what clear convex lens.
Convex lens. Okay, thank you, Rebecca. Convex lens is when you're trying to see, you're focusing on one point. So it's not going to spread out. It's just focusing. So it's going to be like the microscope that you're seeing just one object. So you're making emphasis just in one. It can be in a small object. But it's contrary concave. Concave is what you want to see. It's something that is far away and you want to see bigger. So that is the difference that they have.
Okay, thank you.
Yes. Okay. If you don't have questions, so we're going to finish here. Just for you, you can make an experiment together. You can have a bottle, you can have even glass of water, and one it looks like this with a pencil. So you can try to check how it looks the light, how it reflects. So you can have a bottle of water or a glass of water that it must be transparent so you can see it better. And at the end, you're going to see that it looks in this way. It's going to reflect the light in one and in another way. So this is for you. You can try to do this in your house. So you're going to see how the light passes. Yes. No,
Yes.
no homework this week, remember? So
It's
let's
really
stop here.
happy, Miss.
Happy, it's sad, but it's happy, yes. So let's finish here, class. Bye-bye, see you next
Bye, Miss.
Bye-bye.
Bye.